Hello, I am Mr. Murphy, and today in this video we're going to be looking at the second of a three-part series looking at power standard number 12. In this power standard we're looking at an equation for a parabola in vertex form, and in this portion of the video we're going to be looking at how to find the x-intercepts for a parabola in vertex form. But before we do that, there's some things that we need to make sure that we understand in order to be able to successfully find those x-intercepts. The first thing we need to understand is this theorem, the absolute value square root theorem. What this theorem states is that when we take the square root of x squared, our answer is not simply x. A lot of people think, oh, the square root of x squared is going to be x, but that's not the case. This theorem tells us that the square root of x squared is actually the absolute value of x. Why is that important? Well, let's look at a couple of these examples. The first one here says x squared equals 36. Well, again, if I wanted to solve this to figure out what x is, I'm going to take the square root of both sides. But again, the square root of x squared is not just simply x, it's the absolute value of x. And the square root of 36 is going to be 6. Now, knowing what we do know from absolute value is that the absolute value of a number is always going to be the positive value of that number. So there's actually two numbers I could take the absolute value of to get 6 as my answer. I could take the absolute value of negative 6 and get 6, or I could take the absolute value of positive 6 and get 6. There's two possible answers here, 6 and negative 6. Because again, if I put either one of these values in the absolute value, I'm going to get 6 as my answer. Or another way to write your answer would be to just simply write it as x equals a positive or negative 6. Let's look at this other example. An important thing to note about equations in this form, 2x squared equals 50, is before I can take the square root of anything, I need to get the x squared by itself. I can't just take the square root of both sides here. Otherwise, I'm not going to get the right answer. So before I can, like I said, before I can do anything, I need to get the x squared by itself by dividing 2 on both sides. That gives me x squared equals 25. And now when I take the square root of both sides, again, I don't get x equals 5, I get the absolute value of x equals 5. And that tells me I'm going to have two answers. My answers are going to be a positive or a negative 5. Well, that's the first thing we need to know in order to find the x-intercepts. The second thing that we need to know is, well, what is an x-intercept? So let's take a minute to look over here at this graph and see what we can learn. The first thing that we're going to look at is, well, yes, an x-intercept is where it crosses the x-axis. Seems like it makes sense. But the one thing that you need to remember is this is a coordinate. So each of these are coordinates where x is some number and y is always going to be 0. For example, this one on the left here could have been where x was negative 2 and y was 0. And this one on the right could be where x is 5 and y is 0. So anytime that we have an x-intercept, the value for y is always going to be 0. So that's important. In order for us to be able to find the x-intercept for these problems, what we're going to have to do is we're going to have to replace y with 0 in that equation. So let's look at some examples now. Here we have the equation again in vertex form is y minus k equals a times x minus h squared. We're asked to find the x-intercepts for the parabola with this equation, y plus 8 equals 2 times x minus 5 squared. So again, what we just learned is that the x-intercept is where y is 0. So I'm going to replace y with 0. And now I want to solve this equation. Well, it's pretty obvious here on the left that I'm going to have, well, 0 plus 8 is going to be 8. So this is the equation that I have to solve. If you notice, my x is hidden inside those parentheses, and those parentheses are contained by an exponent there that's squared. I can't do anything with what's inside of the parentheses until I get rid of the square, and the only thing that undoes a square is a square root. But like we just learned in the previous examples was that in order for me to take the square root of both sides, I have to make sure that that piece, in this case the x minus 5 being squared, is by itself. So I need to get rid of this 2. So I'm going to divide both sides by 2. And now I can take and get rid of the square by taking the square root of both sides. And the square root of 4 is 2. I'm going to write this over here now. But now, just like before, the square root of x squared was the absolute value of x. The square root of this whole chunk, the x minus 5 being squared, would be the absolute value of x minus 5. So the square root of x minus 5 being squared is that absolute value of x minus 5. So now there's two things that x minus 5 could be. We could have x minus 5, what's inside of there, could equal a positive 2. Or that x minus 5 that's inside the absolute value could also be a negative 2. So there's going to be two separate scenarios, x minus 5 equaling 2, or x minus 5 equaling a negative 2. So now I'm going to solve both of these equations. I'm going to add 5 to both sides for this one. So I could get x equals 7. I'm going to add 5 to both sides for this one, and I would get x equals 3. So my x-intercepts are where x is 7 and where x is 3. Now remember, these are coordinates. So my x-intercept would be the coordinate 7, 0, and the other x-intercept would be the coordinate 3, 0, because remember, the reason why y is 0 is because that's the case for an x-intercept. So I want you guys to take and see if you can find the x-intercepts for this parabola. So why don't you guys go ahead and pause the video and hit play when you're ready to check your answer. Okay, let's see how you did with this one. Again, if I replace y with 0, 0 plus 24.5 is just going to be 24.5. So that's how I'm going to write this. Now again, we need to get rid of that 1/2. So to get rid of that 1/2, I'm going to, you could look at it as dividing both sides by 1/2, but a better way to look at this would be to multiply both sides by 2. And when you do that, you're going to get rid of the 1/2 on this side. And again, we're multiplying 2 on this side, and we end up getting 49 equals x plus 3 squared. So now in order to get rid of that square, I'm going to take the square root of both sides. So I do get square root of 49 is 7, but remember I have the absolute value of x plus 3 on the right here. And again, inside of the absolute value here, there's two things that we could have. The absolute value of 7 would be 7, and the absolute value of negative 7 would be 7. So I'm trying to figure out what values for x would give me 7 and negative 7. So I'm going to have two equations. So in the first equation, I would subtract 3 from both sides. When you do that, you would get x equals 4. And in the second equation, when I subtract 3 from both sides, I'd get x equals negative 10. So my x-intercepts in this case are going to be where x is 4, y is 0, and where x is negative 10 and y is 0. So hopefully you have a better understanding now of how to find those x-intercepts. And now moving on, you can watch the next video to how to find the y-intercepts of a parabola. And good luck.